done this topic before in your previous classes. So force का हमें basic idea है, right? We know we have a basic idea. So there are three terms we have here: force, thrust, and pressure. So any idea the basic difference between these three terms and what is force?
Force is a like push or pull of an object.
Yes, it is an external effort in
When
the
we
form
push
of
or
force.
pull or pull the object.
Okay, suppose I have something. I have a table right in front of me, and I'm pushing the table, but it is not moving. So have I applied any force or what else? What?
Yes.
Yes, I
Yes.
have applied
It's
force, but
thrust.
that force is
It's thrust.
insufficient to move the table, right? We need to apply sufficient force to move any object, right? So if you apply force on an object, then its state of motion may or may not change. It depends upon that how much force we apply, right? If we are applying
Mm.
sufficient force on it, only then we can change the state of motion. Otherwise, we cannot change the state of motion, right?
Mm.
Yes.
So force is an external effort in the form of push or pull. So when you push an object or pull an object, you are applying an external effort on it. You are applying external force on it, right? And the SI unit of measuring force is Newton. We measure force in Newton, and
Newton.
Newton is denoted by capital N. ठीक है?
Mm.
Any doubt? Clear?
No.
Now
Yes,
we
ma'am.
have another term here, and the term is thrust. So we need to understand the basic difference between force and thrust. See, thrust is the force exerted perpendicularly on any object. Suppose, look at this. If I'm applying force in any direction, we can apply force in any direction like this or that, right? किसी भी direction में we can apply force in any direction from anywhere. And that's called force. But if we apply force perpendicularly on any object, if the force is acting perpendicularly like this, normally on any object, then it is called thrust. So thrust is basically the perpendicular force. As you can see here, we are pressing the nail, right? So we are applying
Mm.
force on the nail perpendicularly. So this kind of force is called thrust. So when we apply force on an object perpendicularly or normally, then it is called thrust. So thrust is also force, but it is the force in perpendicular direction, and therefore the units of both you can see it is Newton for thrust as well. Similarly, we have pressure. Pressure is the perpendicular force per unit area. So how much force we are applying on a unit area is called pressure. And the force has to be perpendicular. Force is acting perpendicularly, means it is thrust, which is acting on the object. And we can also write force exerted perpendicularly on a unit area, or we can write thrust per unit area. Okay.
Mm.
Yes.
So thrust per unit area or force, perpendicular force per unit area is called pressure. And because here we are dividing force by pressure by area, no, pressure is force upon area,
Mm.
right? Because pressure is force upon area and force is measured in Newton, area is in meter square. So pressure is Newton per meter square, right? So you look at these two pictures here. So where we have more area of contact? In case of thumb or a nail, where is
What?
area of contact greater? Area of
Um.
contact. This is the area of contact. Area of contact. Suppose I'm pressing my palm with a finger. Then area of contact is a circle. Look at this. It is a circle. So where do we have greater area of contact? In which case out of these two?
In the first one.
In the first one, we have more area of contact. So where will we feel more pressure?
Um. First one.
First one.
Are you sure about it? Okay, do
Oh,
you have
second
your
one.
pen? Do you have your pen in your hand? Show me your pen.
Yes.
Yes.
Show me your pen. Okay, now press the pen, no, the needle one, and on your hand.
Yes.
ठीक है, अब इसको turn करो. Other side, take the other side and press from that side. Press now. Yes. Apply approximately the same force. Where are you feeling more pressure?
This
The
one.
needle one.
Needle one. Why?
Because it's
Because
like
less
because
area, more
it's
pressure.
Because it has pointed end. No, it is pointed, and area of contact is less, and therefore we feel more pressure.
Mm.
So where we have less area of contact means more pressure. So also pressure is force upon area, right? So you can see we are keeping force in the numerator and area in the denominator, no? And because we are
Hmm.
keeping force in the numerator, and if we increase the force, then pressure will also increase. And area is in the denominator. So if we increase the area, then pressure will decrease because they are inversely related. Pressure and force, they are directly related. Both are in the numerators, no?
Hmm.
And pressure and area, they are inversely related because area is in the denominator and pressure is in the numerator. So they are inversely related. Inverse relation means if you increase one quantity, other quantity decreases. Right? And direct relation
Hmm.
means one is increased, other will increase as well. Clear?
Yes.
Next is the definition of force. Force is an external effort in the form of push or pull, which produces or tries to produce motion in a body at rest. Suppose an object is at rest. It is not moving at all. It is at rest and we are applying force on the object to move it. So object may or may not move, right? That depends upon the quantity of force and the strength of force that by which we have applied on the object, right? And stops or tries to stop a moving body. If an object is moving already and you are applying force on the object in the opposite direction to stop it, then object may or may not stop. Again, it depends upon the strength of force. Okay? If the force is sufficient enough, only then the moving object can be stopped. But if the force is insufficient to move it, then we cannot, stop the object. Right?
Yes.
Third
Hmm.
point is it changes or tries to change the direction of motion of the body. Means if the object is moving in a certain direction and we are applying force to change the direction of the object, then its direction may or may not change. Again, it depends upon the quantity of force, right? If the strength of force, if the quantity of force is sufficient enough to change the direction, only then its direction can be changed. Otherwise, we cannot change it. Next
Yes.
is we have a note here. At least two objects must interact for a force to come into play. Means there should be a kind of interaction between two objects. Interaction doesn't mean that there should be a physical contact between two objects. Okay? Without physical contact as well, object can interact. For example, in case of gravitational forces, Earth revolves around the sun. So there is a kind of force of attraction between the Earth and the sun. But do you see any physical contact between sun and Earth?
No.
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 Yes. So there is no physical contact between the sun and the earth, but still we see that earth revolves around the sun. So there is a kind of force which is,
Hmm.
keeping the two things, the sun and the earth together, but we do not see any physical contact, any touch between these two objects, right? So interaction means that they are, somewhere bounded to each other. It doesn't mean that they are in physical contact with each other. Okay.
Hmm.
Yes, ma'am.
Now please write this. So the next topic is magnitude of force. Magnitude of force because force is a vector quantity. We had done physical quantities, right, in the previous chapter, and there we had discussed scalar and vector quantities. So do you have any idea what vector quantities are?
Vector quantities.
Yes. We had done this now for distance and displacement. Distance is a scalar quantity, displacement is a vector quantity, speed is scalar,
Yes.
is vector, acceleration is vector, force is vector.
Displacement was where we we go like straight in a line.
Yeah. That is the shortest path that we take from
There,
initial to final
there's
position.
yes, short.
So what are vector quantities? I'm saying that force is a vector quantity. It has both the magnitude as well as direction. Okay. So quantities which have both the magnitude as well as direction are called vector quantities. For example, velocity. When we say that the object is moving with certain speed in a particular direction, then we are adding direction to speed, it becomes velocity.
Hmm.
Okay. So here we are considering only the magnitude of force. Magnitude of force is the numerical value of force. Is the numerical value of force. It is a strength of force. How stronger or how weaker the force is its magnitude, right?
Yes.
Magnitude means the strength of force, right? Strength means stronger or weaker. How much force is acting on an object is the magnitude of force. The quantity of force or the numerical value of force, right?
Hmm.
Next is direction of force. So if we have, because force is a vector quantity, so we consider both the magnitude as well as direction. So if we have a number of forces and we are applying the forces in the same direction, then they add to one another. For example, in this particular case, you can see, look at the screen, Pritesh. Pritesh, what are you looking at? Are you looking at the screen?
I was writing the.
Okay, see, look at this, because here in this particular case, we have a trolley and we are applying a force of 60 Newton and 30 Newton on this trolley. So both the forces are acting in the same direction towards right, to the right. So the object will move to the right with a force of 90 Newton. So when two forces are acting in the same direction, then they add to one another. Okay, then the resultant force, the word that we use here is the resultant or the net force or the total force, you can say. Total force, net force, resultant force is 90 Newton. But if the forces are acting in the opposite direction, then we take the difference of the two forces and the object moves towards the force which has greater magnitude. As you can see in this particular case, we have a trolley and there are two forces acting on it. One is 10 Newton, other is 30 Newton, and the forces are acting in the opposite direction. Then the object will move towards the greater force in the direction which is, towards the greater force. As you can see here, 30 Newton is greater than 10. So object will move towards 30 Newton force. Okay. And how do we get the net force?
By adding the force, like.
See, we add when the forces are acting in the same direction.
Yes, when the forces are acting in different directions and we subtract
Then we
them.
subtract. So what is the resultant or net force we are getting here in this particular case?
20.
It is 20 Newton. And how are we getting it? By subtracting 10 from 30 Newton,
Hmm.
right? And what is the direction of the net force?
Um,
What is the direction of the net force?
right.
Towards the greater force, towards 30 Newton force. No?
Hmm.
Please write this.
Okay.
Next is we have a numerical problem here. Ramesh and Shyam were exerting forces F1 is equal to 175 Newton and F2 is equal to how much is this force?
275 Newton.
Yes. So they are exerting forces F1 and F2 respectively. And if the forces are acting in the same direction, then we have to find the net force. If the forces are acting in the opposite direction, then again we have to find the net force. Can you do this?
Hmm.
Okay, the two forces they are exerting on the object. One is 75 Newton, and the second force which Sham is exerting is 275 Newton. And the question is that we have to find the resultant force and the direction in which the box will move. Okay, so first we'll find the resultant force. Resultant force is the magnitude of force, and the direction in which the force is acting is the direction of the greater force, right? It is the direction of the resultant force. And box will move in the direction of greater force. All right. So if the forces are acting in the same direction, then there is no doubt that the object will move in the same direction where the forces are exerting on the object, right? But if the forces are acting in the opposite direction, and then in that case, the object will move towards the force with greater magnitude. The one who is applying the greater force, object will move in that particular direction, right?
Yes.
So the first case is forces are acting in the same direction. Can you find this? What will we do in the first case?
In same directions, 275 plus 175.
Yes, we are going to add the forces to get the net force. It is 450 Newton in the first case. And what is the direction of motion?
Um, Direction is like 475 Newton.
450 Newton
Is
is the net force, right? And direction is the direction of the forces, direction which the forces are acting. The object will move in the same direction, no?
Yes.
Yes. So direction is the direction in which the forces act. No? Because both the forces are
Yes.
acting in the same direction, then the object will move the direction where the forces are acting.
Hmm.
And what if the forces are acting in a opposite direction? Then what will we do?
Then we'll find the like we'll subtract both of them,
Then we
275 and
subtract the
175.
forces. And the greater force, we can subtract the smaller one from the greater one,
Hmm.
right? And we get the net force. Like here in this case, we're getting 100 Newton. And what is the direction of direction of motion?
Where the greater motion is
Greater
like,
force. Greater force is acting.
yes,
Yes,
like 275 is going in
right.
that direction.
So direction in which the larger force is acting is the direction of the
Hmm.
net force, 100 Newton force. So the net effect of force is, it is 100 Newton. So 100 Newton is responsible for the motion of the object. In the first case, 450 Newton is responsible for the motion of the object. So object can move faster in the first case because, we are getting greater force, 450 Newton. While in the second case, when the forces are acting in the opposite direction, then we are getting a smaller quantity. It is just 100 Newton force, and the object will move relatively, with less speed and towards the direction in which the larger force is acting. Now, please write
Hmm.
the solution. Effects of forces. So when we apply force on an object, so what are the effects of force?
They change their directions like that.
Yes, direction of the object can be changed. And what else?
Um,
Ritesh, you can also respond, no?
Yes, ma'am.
Please tell me the effects of force. You're applying force on
Force.
an object. So what are the effects of force that you can see?
Um, Pressure on the object.
Yes, pressure can be felt because we are applying force.
The change of their shapes.
Shape may change. Yes, of course.
Um,
Hmm. Shape of the object can be changed. If the object is at rest, it can start moving. If it is moving already, then it can move faster. We can increase the speed, we can decrease the speed. Suppose object is moving in certain direction and you're applying force in the same direction where the object is moving, then the speed of the object will increase. And if you're
hmm,
applying force in the direction opposite to the direction in which the object is moving, then the speed may decrease, right? You can change the direction. If you can change the speed, you can make the object moving if it is at rest. You can, stop the object if it is already moving by applying force in the opposite direction, right?
hmm,
So may make an object move from rest, may change the speed of the object if it is moving. No, we can change the speed. How will we change the speed? If the object is moving in this particular direction and you're applying force in the same direction, then the speed will increase. But if you're applying force in the opposite direction, then speed may decrease. No, it depends that in which direction you're applying the force. Third, may change the direction of motion of the object. Means if object is moving in certain direction and you are applying force in some other direction, then the direction of the object may change. Fourth, may bring about a change in the shape of the object. Shape of the object can be changed. If the object is, some, for example, let's take an example of matchbox. It is empty matchbox and you're applying force and it becomes tilted, no? We can
yes.
shape or dough. Dough is a good example. When we make a dough and we apply force on it, we can change its shape. On
Hmm,
clay, on applying force, we can change the shape, no?
hmm,
And may cause some or all of these effects. Means the one or two effects can be uh, seen or felt, no? If we apply force on
yes.
an object. Here we have a note. None of the above effects can take place without the application of force. If we are not applying force on the object, then the effects cannot be observed. Next topic is state of motion. So it is a very important topic. Can you please tell me what is a state of motion? What is your state of motion at this moment?
sit like
Rest.
rest.
Rest. So state of motion doesn't mean that object is moving. It means that the state of motion means the state of rest is also state of motion. State of rest is a state of zero speed. No?
Hmm.
So rest and motion both are the state of motion. If you are at rest, your state of motion is rest. If you are moving, your state of motion is motion. And it is described by the speed and direction of an object. If you know, we can define the state of motion of an object by considering the speed or the direction in which the object is moving. State of rest is considered to be the state of zero speed. Means if the object is not moving, it is at rest, then it is, at zero speed because it is not moving at all, right? So state of rest is considered as state of zero speed. Here we have a question here. Please read the question now.
Will the applications of force always result in change in the state of motion?
Will the application of force always result in the change in the state of motion? What is the answer?
Mm,
No, ma'am.
Tell me.
Uh,
We are
I
applying
think no.
force. Yes, we are applying force on an object. Question is, will the state of motion change if we are applying force on it? Is it mandatory that every time when we apply force, the state of motion has to be changed?
No, ma'am.
No.
mm,
Answer is no. Change in the state of motion occurs only when the applied force is sufficient enough to change the state of motion. If we are applying sufficient force on the object to make it move or to, make the object at rest, only then its state of motion will change. If we are applying insufficient force, then state of motion will not change. It depends upon the quantity or the magnitude or the strength of force, right? Which we are applying on the object to change its state of motion. Please write this, it is important. Please write the heading. Factors on which the effect produced by the force on an object depends on. So what are the factors on which the effects produced by the force on an object depends? See, force, if you're applying force on certain object, on any object, then we have to consider the factors on which the effect of force depends on. Means आप जो force apply कर रहे हो उसका effect कौन कौन से factors पे depend करता है? Depends upon the magnitude of force, the strength of force, right? How stronger or weaker you're applying force on the object. It depends upon the direction of applied force, in which direction you are applying force on the object, right?
mm,
See, the force you are applying on any object, this is the question, that how will that force affect the, state of motion of an object, right? How
mm,
will that force affect the state of motion? How will force affect the object is the question. Okay, so the force is responsible, the strength of force is responsible, the direction in which we are applying the force is responsible for the effect, and the point of application of force is also responsible for it. Okay, so these are the factors.
mm.
Please write this now.